For years, we've been talking about AI living on our screens. AI that generates text or creates images. But that whole era, it's fading fast.
It really is. The game has totally changed. We're moving way beyond the sci-fi trailers now. AI has a body. It's seeing, it's moving, and it's reacting in the real world.
And the stakes are just fundamentally different. A mistake on a screen is a typo, maybe a bad recipe. But when physical AI makes a mistake in a factory, in a car, it's immediate. It's physical. And it is incredibly costly. It changes reality.
Welcome to the deep dive. Today, we are unpacking what our sources are calling the most important tech convergence happening right now, the rise of physical AI. And here's our argument. The screen era of AI is, for all intents and purposes, over.
Yeah, and this isn't some far-off 10-year prediction. This is 2026. Physical AI is already running huge logistics operations. It's streamlining supply chains. It's controlling safety systems in our cars. Most people still think this is a decade away.
Exactly. So our mission today is to really break down the four big shifts, the tech and the economic forces that are driving this massive change. We're moving from machines that just react to partners that can actually predict.
So that means we're going to dive into predictive math, this idea of collaborative robot learning, why hyper-specialized AI is winning, and this whole new data economy where robot performance itself becomes a tradable asset.
Okay, let's get into it. First up, what exactly is physical AI, and what's the economic engine driving this whole thing?
So let's define our terms. What is physical AI? At its core, it's intelligence that's embedded right into a machine that has to deal with the real, messy, unpredictable world. We're talking systems with cameras, with sensors, with actuators that let them see and move and apply force.
It's the absolute difference between thinking and doing. A digital AI, like a large language model, lives safely on a server. It processes text. Physical AI has to deal with motion, friction, physics. It has to survive in the real world.
And that reality is the key differentiator. If a digital model hallucinates a fact, it's an annoyance. But if a self-driving car, a perfect example of physical AI, hallucinates a barrier that isn't there, or worse, doesn't see one that is, the consequences are immediate and severe.
It means that reliability and safety are just infinitely more important than creativity. And what's so fascinating is that this isn't just a robotics trend. It's really a chip war, a race to build the fastest, most reliable physical brain.
Right. You see players like Nvidia, ARM, all the big automakers. They're all battling to build the compute architecture for these things. And the money involved just confirms how high the stakes are.
Oh, absolutely. Our sources are projecting that the automotive chip market alone, which is basically the prototype brain for all physical AI, is going to hit $123 billion by 2032. That is an 85% jump in less than a decade, just for the brain.
And that kind of growth, that level of investment, it points to one thing that is absolutely non-negotiable: massive on-device compute. The thinking has to happen inside the machine, in real time, no waiting for the cloud.
Think about it. For physical AI, latency is death. If a robot welding a car frame or a car on the highway has to send data to the cloud, wait for a decision, and get it back, it's over. The moment has passed. The calculation has to be local, instant.
So with all this money and technical demand, what's the actual bottleneck right now? Are we still just waiting on better hardware?
Surprisingly, no. Hardware's still a challenge, but the real bottleneck has shifted. It's the software on the chip, that predictive math, and the power to run it in milliseconds.
Okay, that's a perfect transition to our first major prediction. The next big leap forward is coming from math, not just from new hardware. That feels a little counterintuitive. We always think we need more power.
I know, it is a weird shift to think about. Most people expect, better motors, stronger arms, faster sensors, but the real upgrade is in the math underneath it all. Current industrial robots, they're reactive. They just follow a very rigid script.
And if anything unexpected happens, like a part is in the wrong place, they just stop. They enter a failure state and wait for a person to come fix it, which is so inefficient.
But tomorrow's systems, the ones running this new predictive math, they work completely differently. They actually model the consequences before they move. They're simulating possibilities instead of just reacting to what the sensors tell them.
So we're talking about concepts like dual numbers and jets. That sounds like some pretty heavy math. Can you break down what that actually lets a robot do?
What's amazing here is that we're basically giving the robot calculus tools that let it see the future. Think of it like a chess master seeing 10 moves ahead. The robot is doing that with physics in real time. It's calculating the future friction, the inertia, all of it, before it even commits to a move.
So a robotic arm doesn't just grab a part. It first simulates 5 different ways to grab it, forecasts if a tiny change in angle will cause a problem later on, and then picks the best path. And it does all that in a fraction of a second.
Yeah, this idea of modeling consequences is a huge, huge leap. And I'll be honest, I still wrestle with the subtle implications of state drift myself.
That's a really important concept. What exactly is state drift here? Why is that predictive layer so necessary?
It's when the world changes really slowly. So slowly, the AI doesn't see it as a sudden error. Maybe the robot arm heats up over a long shift, or the floor gets a little dusty. Its performance just degrades little by little until it fails. Predictive math can catch that slow slide before it becomes a catastrophe.
So the result is this adaptive control that just feels intuitive. It leads to faster work, fewer mistakes. We're finally building machines that are smarter, not just stronger.
And to work, it has to be incredibly fast. The machine has to anticipate the next 500 milliseconds of reality on device with zero help from the cloud.
That need for speed brings us to prediction number 2, the death of the solo robot. For decades, automation meant one robot in a cage following one program.
And that era is over. It's just too slow, too inefficient, too rigid. The next wave is all about imitation learning, about cooperation.
So robots will literally watch humans or watch other robots, copy what works, refine it, and then share that new skill across the whole fleet.
Exactly. True peer-to-peer learning is finally here. We're getting away from that old model of programming each robot one by one.
And that changes everything on the factory floor, especially setup time. Instead of spending days programming every single robot for a new task, you just show one robot how to do it.
And the rest of the team just gets it instantly. That knowledge sharing makes setup 5, maybe 10 times faster, and the adaptability is just, it's exponential.
So if a part shows up on the conveyor belt at the wrong angle, the robots don't just freeze up, they can adapt together in real time because they can share the solution to the new problem.
Yeah, companies like Universal Robots are already doing this with multi-arm systems, but the price of entry is dropping fast. For this team learning to really work, you need the communication standards, the safety protocols, and the software to orchestrate it all. Those pieces are finally catching up to the hardware.
So it's not really about the arms anymore. It's about how they talk to each other safely.
Orchestration tools, communication standards, and safety rules are catching up to enable team learning.
Okay, let's talk business. Prediction number 3 is a big one for anyone actually paying for this stuff. Vertical AI is crushing generic tools. For the last couple of years, the hype was all about general AI that could do anything.
But the hard lesson learned in manufacturing in 2026 is that a tool that tries to do everything usually does nothing well. If you're running a business, you need a system that does one job, but does it perfectly.
And that's vertical AI, pre-trained, task-specific systems. We're talking AI welding, AI finishing, AI assembly. These aren't just concepts anymore. You can buy them off the shelf right now.
This is such a big shift. I remember just 5 years ago, everyone was trying to build that one general-purpose factory robot, and it was terrible at everything. This move to specialization, just do welding, just do pick and place, that's the industry growing up.
Take Siemens' Somatic Robot Pick AI. It's a perfect example. It uses deep learning tuned for one thing, picking up complex objects. It ships ready to go with hardware you already have. That eliminates weeks of custom programming.
Welding is maybe the best use case. It requires these tiny constant adjustments. A human is great at it because seams can shift, temperatures change. Well, now AI vision can track the seam, and machine learning adjusts the heat, the feed rate, all of it on the fly. You get perfect quality every time.
The bigger impact here is that automation is becoming more like buying an appliance. It's not just for massive companies with huge R&D budgets anymore. This is democratizing efficiency for everyone.
And while factories are leading the way, we have to look beyond them. So outside of logistics, which industry is going to feel the impact of vertical AI the most?
I think it's clear that while logistics is already using it, retail is absolutely next. Stocking shelves, taking inventory, even basic customer tasks. Our fourth prediction really gets into the new economy being built around all this. Robot data is about to become a tradable asset.
And this solves a massive bottleneck for AI development. Robots generate a ton of information. Sensor readings, error logs, vision data. It's incredibly valuable real-world data, but right now it's all locked away inside each customer's facility.
Which stalls improvement. AI developers need that high-quality real-world data to train the next generation of models. Not simulations. The best data is just sitting there, completely unused.
The solution is these new secure data exchanges. They're opt-in systems that let companies share anonymized performance data safely with the developers who can actually use it.
So we're talking about welding robots sharing de-identified data on theme quality, or assembly robots sharing their error logs. This isn't just random noise. It's perfectly structured, high-quality fuel for training new models.
And it creates this amazing virtuous cycle. The manufacturer gets a new revenue stream, the customer gets better AI tools trained on real-world conditions, and the developers get the data they need.
Whoa. Just imagine scaling that. A continuous improvement loop across every factory and warehouse on the planet. The rate of optimization would become truly exponential.
Exactly. It flips the script on data scarcity. The core idea is so simple but so powerful. Every single robot that gets deployed makes every future robot smarter.
But of course, the big question is always going to be about privacy and trade secrets. Can we be sure customer data will be protected in this new model?
Data is being anonymized, privacy preserved, and shared safely with customer permission via opt-in systems.
So let's put it all together. What does it mean when you combine these four trends? We have predictive math for anticipation, collaborative learning for smarter teams, vertical AI for specialization, and a data economy to fuel it all. It means convergence.
And the automotive industry is the biggest driver of that convergence. It's colliding head-on with factory automation. The powerful, tested systems being built for self-driving cars are migrating straight to the factory floor. The robot gets a pre-tested brain.
You could see it in all the announcements from shows like CES 2026. Ford's selling a hands-free system by 2028. Mercedes is debuting theirs this year. And Nvidia is supplying its architecture to major automakers like Geely.
And here's why Nvidia is winning. They're taking the same architecture they used for training huge language models and just applying it to real-time physical control. Jensen Huang said this is already a giant business for them. This isn't a future thing. It's happening right now.
And you see the exact same thing with humanoids. It's now confirmed that humanoid robots from Google DeepMind, from Boston Dynamics, from Hyundai, they're hitting factory floors for actual production work in the next few months. Not just demos.
And that's only possible because these physical AI systems are finally robust enough to reason and act in those messy real-world spaces. They can handle that state drift we talked about.
Which is all fueled by that explosion in compute. The central brain of the car, which is the prototype for the robot brain, is becoming, as one expert said, quantum leaps bigger, hundreds of times as big. But it look like separate trends, cars, robots, chips, all one converging system. Okay, let's bring this deep dive home. We've laid out the four big forces driving this shift to physical AI. You've got predictive math for anticipation, cooperative learning for smarter teams, specialized vertical AI for immediate value, and this new robot data economy fueling it all.
Yeah, and this is not sci-fi in a lab. This is a fundamental restructuring of our economy and technology that's happening right now in 2026. We're moving away from machines that just follow orders toward cooperative partners that can learn and reason and even predict what's next.
We do have to acknowledge the workforce implications here, which our sources were clear about. We're looking at a global drop of maybe 10 to 15% in low-skill manufacturing and routine retail jobs over the next 5 to 7 years.
That's a huge transition, a massive one. But it's balanced by this skyrocketing demand for specialized engineering roles, the people who build, maintain, and train the vertical AI models we were just talking about.
It's a huge and probably painful shift. It demands completely new skills.
It definitely is.
So here's a final thought. If physical AI is truly defined by its ability to use predictive math to survive in messy, real-world environments, what complex variable job that you currently think is safe from automation will be the very next one solved by a vertically trained predictive machine? Something to think about as you start seeing these systems pop up all around you.
It's definitely worth thinking about how fast those goalposts are moving. We'll see you next time.